Hello, everyone. This is Kevin Nelson, and I'll be speaking to you today about database. The literal definition is an organized collection of data, and it typically involves the collection of schemes, tables, queries, reports, views, and other objects. And the data is typically organized to model aspects of reality in a way that supports processes requiring information. A big key term within databases are database management systems. Another major development within databases is the database management system. It's a computer software application that interacts the user, other applications, and the database itself to capture and analyze data. The most well-known DBMs include MySQL, PostgreSQL, MongoDB, Microsoft SQL, Oracle, among others. Two platforms of database management systems include general and specific. General purpose DBMs aim to meet the needs of as many applications as possible, which adds to the complexity. However, the fact that their development costs can be spread over a large number of users means that they are often the most cost-effective approach. On the other hand, with specific database management systems, database designers and database administrators interact with the DBMs through dedicated interfaces to build and maintain the application databases, and thus need some more knowledge and understanding about how DBMs truly operate and the DBM's external interfaces and tuning parameters. There are four main groupings of databases. Existing DBMs provide various functions that allow management of database and its data, which can be classified into four functional groups. First, definition. Second, update. Third is retrieval. And lastly, administration. With definition, data definition is the creation, modification, and removal of definitions that define the organization of the data. Referring to updates, this refers to the insertion, modification, and deletion of the actual data. With retrieval, this consists of providing information in a form directly usable or for further processing by other applications. The retrieved data may be made available in a form basically the same as it's stored in the database, or in a new form obtained by altering or combining existing data from the database. And lastly, the administration category deals with registering, monitoring users, enforcing data security, monitoring performance, maintaining data integrity, dealing with concurrency control, and recovering information that has been corrupted by some event, which sometimes happens in unexpected system failures. So a little history on databases. They're typically defined by three eras. In the 1960s, it was known as navigational DBMs. In the 70s, it transitioned to relational DBMs. And most notably in the 80s, this was the era of post-relational DBMs. And these three factors established databases' relevance in terms of technology and allowed for them to evolve to the resource they are today. Another key aspect of databases are database models. A database model is a type of data model that determines the logistical structure of a database and can fundamentally determine in which manner data can be stored, organized, and manipulated. There are three different levels of databases in which they can be viewed. The external level defines how each group of end users sees the organization of data in the database. A single database can have a number of views at the external level. Next, the conceptual level unifies the various external views into a compatible global view. It provides all external views and it is out of the scope of the various database end users and is rather of interest to database application developers and database administrators. And finally, with the internal level, this is the level of organization within a DBMS that is concerned with cost, performance, scalability, and other operational matters. It deals with the storage layout, using storage structures such as indexes to enhance performance. Occasionally, it stores data of individual views, computed generic data, and finally, balances all external views, performance requirements, possibly conflicting in an attempt to optimize overall performance. So why are databases relevant? First, databases provide storage which act as the container of the physical materialization of a database. Second, databases provide detailed security with deals of all various aspects of protecting the database, content, its owners, and its users. And finally, databases allow for backups, which brings a database back to a previous state, allowing complete availability at any certain project. Listed below are the main competitors within database. And in the news, these are some local headlines of databases within October. Thank you everyone for listening today. Have a good day.